Hello dear subscribers and viewers of this channel. My name is Andriy Severinov, and I have been working on the simulation of metal casting processes for many years. My colleagues and I decided to record this training course in which we show, step by step, how to work with the metal casting process simulation system Poligonsoft. In each video, we will demonstrate the main stages of working with the program, how to prepare the 3D model, how to perform calculations, how to analyze the results. Today is our first lesson dedicated to the construction of finite element meshes. I will show you how to work with the mesh generator and what the main requirements are for obtaining a quality mesh. Additionally, we will learn how to search for and correct problems using the automatic correction tools available in Poligonsoft. Let's get started. To start working, we will need a 3D model of the casting made on a 1:1 scale. The model should include all the main elements that influence the outcome of the casting. The casting itself, the mold, the gating system, as well as all auxiliary elements like exothermic inserts and insulators. For the proper functioning of Poligonsoft, the 3D model must meet the following requirements. If we isolate the mold and deactivate the visualization of the casting, we should see a simple cylinder. When designing the model, theoretically, there should be a cavity inside the mold, which means we have to subtract the casting from the mold. However, it is very important not to subtract the casting from the mold in our 3D model, as the finite element mesh must be common at the boundaries between the casting and the mold. We need there to be a single surface in the contact area. If we subtract the casting from the mold in the CAD system, we will obtain two sets of surfaces that contact each other: the inner surface of the mold and the outer surface of the casting. The program's algorithm can find and merge into two adjacent surfaces, but only if these surfaces are flat. For example, it is convenient to separate the casting from the gating system. The contact surfaces of the casting with the mold represent a complex curvilinear surface. For curved surfaces, the presence of a single common surface is a mandatory requirement. To speed up the calculation time, it is considered good practice to avoid small elements smaller than 1 mm and to avoid joining surfaces at angles less than 6 degrees. If a model contains elements of this type, it is recommended to remove them at the design stage in the CAD system. Before us is the startup window of the Poligonsoft system. We can see the mesh button, which starts the mesh generator. Let's start it. To import the geometry of the 3D model we will use, we switch to the geometry preparation mode. We open our model from the Sector A file in step format. You can download the file in the video comments. I go to the menu, choose the import command, select step format, and then choose the necessary file. A window opens with a warning that the model was created in millimeters and offers to replace the units with meters. By default, the mesh generator uses meters as preset units. I suggest pressing No and rejecting the conversion, because it is simply more convenient to work in millimeters. The model is loaded, and here the program offers us to perform body separation. The partition algorithm analyzes the imported geometry, finds common contact surfaces between different elements, and in case they are duplicated, it joins them and then divides our 3D model into elements suitable for further mesh construction. I will press Yes. The geometry import was completed successfully, and the model was loaded. If I want to rotate the geometry, I need to press the left mouse button. To scale, I will turn the wheel, and if I press the wheel, I can move the view. In the left panel of the screen, we can see the history of geometry manipulations. At first, the file was loaded, then two bodies were found, and then the partition command was executed. Before the separation command, the bodies looked like this. Solid 1 is a sand mold, and solid 2 is the casting. Now we only see the sprue. If I deactivate the display of the casting, we see that we have only a cylinder. After executing the partition command, we can already see two separate elements. Inside the mold, additional surfaces appeared. As you can see, all operations were performed automatically. For convenience, I will rename the bodies obtained after the separation to casting and mold. We are done with the geometry. Now we move on to the mesh construction mode. For this, we press this button. A new interface loads, and we see a black screen, as there is no mesh yet, and there is nothing to display. Above, we see the toolbar, which has everything needed to create a mesh. To start, we will set the general mesh parameters for the entire system. For this, we select the item partition 1 in the tree and execute the command create mesh. As we see, our mesh will be called mesh 1. The settings will be applied to all objects within the partition 1 group. A three-dimensional mesh can be built directly, that is, a volumetric mesh, which is what we really need. But to have the opportunity to detect and correct possible errors, it is recommended to first build a 2D mesh on the surface of the elements, and only then build the 3D mesh. We go to the 2D tab. First, we need to select the algorithm for mesh construction. We recommend using the Netcon 1D2D algorithm. 1D2D means that first a one-dimensional mesh will be built, and then, based on it, a two-dimensional mesh will be built. What is a one-dimensional mesh? It is a mesh composed of nodes placed on all the edges of the objects. That is, when working with the Netcon 1D to 2D algorithm, it first places nodes on the edges with a set step, and then builds the mesh surface, that is, additional nodes are placed on the faces that are connected to each other with triangles. Here you cannot directly choose Netcon 2D, because that would mean that the one-dimensional mesh was already built by ourselves. Then we have to set the hypothesis, a set of rules and parameters that will be used for mesh construction. We press the gear button and select Netcon 2D parameters. Here we will indicate the maximum and minimum size of our triangles. Our mold is quite large, so for the maximum size, we set a value of 50 mm, and for the minimum 1 mm. This means that triangular elements with an edge size of no more than 50 mm and not less than 1 mm will be created. What specific size to set in a specific place is determined by the program automatically according to the shape of the surface. If there are large and small surfaces, the mesh will automatically refine on small surfaces. The rules for choosing the maximum and minimum sizes are quite simple. The larger the maximum size, the fewer elements our mesh will contain, and the faster the calculation will be carried out, but at the same time, the accuracy of the calculations will decrease. The minimum size is set according to the size of the smallest surface. Within the smallest element, 2 to 3 triangles should fit. The minimum size is used as a recommendation. If the algorithm finds a surface that is smaller than the minimum size, the program will automatically reduce the minimum size to the necessary value. Then we set the precision. By default, the value is moderate. I will choose the value coarse. This means that the size can change from fine to coarse quite abruptly. If here the value moderate or fine is put, that would mean that the size of the small to the large triangle will change smoothly, and the mesh will look very nice. But in the end, there will be many elements, and if there are many elements, it means that the calculation will take a long time. For casting simulations, the value coarse is quite suitable. We press OK, then apply and close. In the tree, an object called mesh was created. If I unfold it, I will see that the Netcon 1D to 2D algorithm and the hypothesis with our settings were assigned to it. The settings can be edited at any time by right-clicking and selecting the edit item. If we now build a mesh, these rules will apply to both the mold body and the casting body. But I would like the mold to have a larger element size, and the casting to be divided into smaller triangles. We will create a separate mesh construction rule for the casting. It is done as follows. We select the mesh 1 element in the tree and right-click, and here I see the item Create Submesh. Within the global mesh, I will create a separate mesh only for the casting block. Here I have the mesh field. In it, the parent object, mesh 1, is indicated, and there is a line called Geometry. I want to create a separate mesh for the casting. For this, I select the casting element in the tree. I go to the 2D tab, and just like the previous time, I set the NetGun 1D 2D algorithm and the hypothesis. We press the gear and create a new hypothesis. For the maximum size, we set a value of 10 millimeters. With the minimum size, it's a bit more complicated. It is important to remember that the minimum element size should always be indicated the same as the minimum size for the main mesh. The meshes at the boundary between the casting and the mold must be conjugated. That is, they must match. And that means that we should not force the mesh generator algorithm to couple a mesh where, for example, the minimum size is 1 millimeter, and in another body, a minimum size of 2 millimeters is set. The elements simply will not couple, and there will be an error. The maximum size can be different. The minimum for all meshes is always set the same. We set a value of 1 millimeter. The precision again, I put it on coarse. OK. Apply and close. Everything is ready. Now, I can calculate the entire mesh with both bodies. However, we recommend first calculating only the submesh to see if it satisfies us. In case errors arise, they can be corrected without waiting for the calculation of all the elements. I right-click on the submesh and choose the item Compute Submesh, and the creation of elements on the surface of the casting block begins. This takes some time depending on the number of surfaces and the size of the elements. In this case, it doesn't take that long. Done, we see the created mesh. We examine it, and if everything is in order, we proceed to calculate the mesh for the mold. We select the Mesh 1 element in the tree, right-click, and then choose the Compute item. The calculation has been completed, and now we have a 2D mesh on all surfaces of our bodies. Before proceeding to the construction of the 3D mesh, another operation is required. We must execute the command 2D mesh quality. We select the command and see that some elements do not comply with the established settings. Here, we can indicate the minimum angle of our triangles, the maximum allowed aspect ratio, and the minimum segment size. It is recommended to set the value of the minimum length of the 2D segment equal to half the minimum size set in the mesh generation parameters. In our case, we leave all values unchanged. We press Correct and wait for the calculation to complete. Done. Only remains to build the 3D mesh. We find the Compute 3D Mesh command and execute it. The 3D mesh will be built for all elements of our project using the settings established for 2D. At the end of the calculation, we get the final report, where we can see the total number of elements created. Now, we must export all the data for further work in the module master of the Poligonsoft program, where the calculations are performed. We select our main mesh, Mesh 1, right-click, and choose the Export command. Here, we choose the MED format. There are other formats, but this format is convenient because it takes up little space. We write the name of our file and press Save. Everything is ready, but I also recommend saving the entire project in the Mesh Generator's HTF format, as the history of operations we have done will be stored there. In case we need to make changes to our mesh in the future, we will not have to perform all the settings again. That's all. We have finished working here. We close. In the next lesson, we will see how to set the main parameters to perform calculations and also prepare and start the casting calculation. I hope you like this video. Leave your questions in the comments below the video. See you later.